Welcome to SOLIDWORKS for the Engineering Design Process, Lesson 5, Section 1. In this section, you'll learn about the benefits of simulations and finite element analysis to the engineering design process. A simulation attempts to replicate the behavior of a system by modeling it using mathematical tools. Simulations allow you to test products for flaws before they are built, helping to prevent errors early in the design process. It's an engineer's duty to their employer to use financial resources effectively, but they should not forget that they also have a duty to the environment. Simulations allow engineers to fulfill these duties by providing them with the means of analyzing their designs without wasting any material. Simulations are very important to the engineering design process because they reduce the number of prototypes which need to be physically built. In this way, engineers can reduce the time and resources consumed by each iteration of the process. Using SOLIDWORKS, engineers can simulate a design's behavior and make conclusions efficiently on screen. Step 3 of the engineering design process is developing possible solutions. This is a stage where simulations are very useful because you can simulate your design to see whether or not it meets design criteria. Step 4 of the engineering design process is where the best solution is selected. In this stage, simulations can be used to compare the performance of different designs. In finite element analysis, often referred to as FEA, the body of your part is divided into a large number of sections called elements. The grid-like pattern of elements is called a mesh, and each intersection of the elements is called a node. By applying force on each node, FEA can determine how each node will react to certain stress levels. In SOLIDWORKS, FEA is used to verify if the product will be able to handle the stress and strain placed on it prior to the manufacturing stage. For example, it allows you to visualize where your product bends or twists and indicates the distribution of stresses and displacements. SOLIDWORKS provides 5 different simulation analysis packages: SOLIDWORKS Simulation, SOLIDWORKS Simulation Professional, SOLIDWORKS Simulation Premium, SOLIDWORKS Flow Simulation, and SOLIDWORKS Simulation Express. SOLIDWORKS Simulation is included with SOLIDWORKS Premium and allows users to simulate assemblies, welded structures, and offers motion simulation and analysis. SOLIDWORKS Simulation Professional goes beyond the basic simulations offered by SOLIDWORKS Simulation. It includes failure prediction, drop test or impact simulation, buckling or collapse predictions, repeated loading simulation, and thermal simulation. SOLIDWORKS Premium adds a final level of sophistication beyond the capabilities of SOLIDWORKS Simulation Professional by bringing in advanced finite element analysis. It allows nonlinear displacement analysis, the ability to simulate plastic parts, and allows you to simulate vibrations in your products. SOLIDWORKS Flow Simulation is an easy-to-use fluid flow simulator. It allows radiant heat transfer analysis, internal flow analysis, rotating reference frame analysis, transient flow analysis, as well as conduction and convection heat transfer analysis. SOLIDWORKS Simulation Express is the entry-level simulation analysis tool. It's easy to use and allows you to simulate the effects of force and pressure on simple parts. In this lesson section, you learned about simulations and finite element analysis, as well as their relevance to the engineering design process. You also learned about some of the different simulation packages offered by SOLIDWORKS. In the next section, you'll be given a short introduction to Simulation Express, Flow Express, and Motion Analysis.